right, so I'm Sanja. I'm part of the artificial intelligence group. And actually, AI is really blooming these days, right? So everyone knows Siri, right? Can basically answer any questions you throw at it. And then there's Robo that don't ask any question. They just do basically whatever you tell them. And then there's algorithms that beat world champions in really complicated games. But perhaps the most life-changing domain is self or autonomous driving cars, right? Just imagine a car that can drive you to school or work on its own. Just how cool would that be, right? And maybe not so far out, actually, the movies from the 80s might actually come true pretty soon. All right, so all these domains, or most of these domains, are actually powered by this really powerful concept, neural networks, which is a machine learning model. And basically, you give it some data, and then it goes through layers and layers of computation until it basically does whatever you want it to do. All right? And this concept has been around for decades, but it has been since 2012 that actually a group at TEDxUofT really made a significant breakthrough. This was the group of Jeff Hinton here. And this really started to work, at least much better than anything that has been around there before. And actually, Wire just recently posted this top 100 people in the world that have the most influence on the full digital world. And actually, Jeff made it to this list, probably one of the few professors that made it to this list. And what's more impressive, he's actually only a few spots below Taylor Swift. I'd call that a success. All right, so let's start with the beginning of the story, actually my story. So the kid on the left, the cute kid on the left is me, and on the right is my first cognitive agent. So my sister, actually. So you're basically looking at the moment that kind of decided on my life, right? It was AI, so that's what I wanted to do. And you kind of see the expectations, right? So the robot needs to perceive the world, it needs to talk to the person, definitely do stuff for the person, right? And entertain the owner. Right? So, there I was, the first day of my PhD, and how to actually get there. All right, so now we have a robot in the scene or an apartment, and now you want it to actually, bring you coffee or something like that. So at least it should understand it needs to go to the kitchen, it needs to actually, recognize a coffee pot, right? Not to mention sugar or milk, right? So what I started with was the problem of recognition, right? Which basically means that you have a photo, and you want to recognize the object that is on the photo. But what makes this problem really challenging is the fact that there's so many different classes, so many different types of objects in the world. And each object can be basically in any location and in any size and in any viewpoint and so many different poses or number or even abstraction, right? So how can you make a model that can actually deal with this kind of complexity? So what people believed in those days, including me, is that there's some compositionality to objects, right? So objects are composed of parts, like a car is composed of wheels, and then wheels may be composed of other elements, right? So how can we translate that idea to vision, okay? So let's take a very simple example, right? You were a kid, you were probably playing with Lego, right? So you took really simple pieces, and you composed them in a little bit more complicated shapes, right? And you kept doing that until in the end, you had maybe a full sculpture, a full object, right? So how can we translate that to vision? Okay? Well, you can also do something like this. You can start with really small, tiny patches, like little pieces of curves, and then keep combining them until in the end, in the top of this hierarchy, you have something that looks like an object, right? And this model, which kind of preceded this big success of neural networks, actually had a structure, a special structure of a neural net, all right? But by the time, it was actually one of the deepest models that existed. It worked pretty well, so I was super proud of myself. But then Jeff came and kind of ruined the dream. So these are a couple of results. So basically, in the bottom, you see the original image. And then, these colors show you what the model, which kind of sits in the top there, is looking at when it's recognizing objects. So it was doing pretty well. I'm just going to show you a little video.
Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
All right, so this basically brings us to the other issue, right? So now we have a robot in the scene that can recognize the world, but the scene is actually not empty, right? There's people in this world, and these people are gonna want to talk to the robot, right? So in this case, this grandma is saying something, and the robot needs to understand language, needs to understand what the grandma is actually referring to, this little bottle in this case, right? And vice versa, the robot needs to also be able to talk back, right? It needs to engage in a conversation, so it needs to be able to describe the world. And I'm gonna tell a little bit about what we did on this description part. So this is basically what the current systems do. So they take a picture, and then they're able to write a little sentence that describes this picture, right? So a robot takes the picture and basically generates word by word describing what's on the picture. Right? So this would be one example, a man holding a metal ball at a table. Right? But if you look at this picture, it's so much richer than what the caption is actually saying. Right? There's a party, maybe the guy on the left graduated, the guy on the right is worried that there's no more food, right? There's wine. It seems so much more alive than this little caption over here. Right? So maybe we actually want a robot to do more. Maybe they want to understand what these people are actually feeling, and why they're feeling in a particular way, and what they're going to be thinking, and basically what they will do next, or want to do next. So maybe we want a robot to actually write a much more descriptive text about this picture, right? Maybe write a little story that's going to describe it, right? So if we actually had this data, if we had the pictures and the stories, then we would be able to train our neural net that's going to be able to produce this kind of data and this kind of stories. Right? So the question is, we have pictures, but how can we get such really rich descriptions? Okay? And then our idea was, well, books. All right? So books are really rich in kind of bringing the characters to life for you. Right? You really imagine how they look like, what they're thinking and feeling, basically throughout the story, right? And I'm gonna show you one.
As I walked towards the bar across the concrete parking lot, I looked straight down the road and saw the river. Moving apace with the river was a long single line of men, eyes aimed at their feet, walking steadfastly nowhere. I felt an immediate need to get inside.
So basically, just these 3 sentences from this book are kind of really telling you a lot, right? So basically, the author is on a parking lot, and it sees this man walking across the street, and it makes him feel very uneasy, okay? But then this book, Gone Girl, maybe some of you read it, actually was converted into a movie, right? And then you can see the same scene, basically seen from the eyes of the director.
Wow.
So our idea was, can we take a movie and a book, basically a movie that was recorded after a book, and try to align them? So basically take a clip, so each clip from the book, from the movie, and find where it actually happens in the book. Okay, and we can find that text, we can just copy it over to our clip, and then we have the data that we were looking for. All right? But this problem is actually super challenging. All right? So a movie contains 200,000 pictures. Okay? And the book has almost the same, so 150,000 words. So it's really challenging. And furthermore, there's so much diversity in books, right? So here's the longest sentence. This is from American Psycho. One sentence, 400 words. All right? And this is the shortest one. There's so much variety, right? And actually, the student told me it's not possible. So I spent Friday night annotating one movie and a book, and this is what you can come up with. So what you see on the bottom is basically a movie in minutes from left to right. Left is the beginning, the right is the end. And on the top, the red bubbles are sentences in the book. Again, from left is the beginning, right is the end. And the edges that you see is basically correspondences. That means that a particular chunk in the movie is corresponding to the sentence in the book. So you can actually do it. It took me 10 hours for a 2-hour movie, so it's not too bad. And then we actually hired an annotator who basically was just watching movies and reading books for 1 month. And she even got paid for it, so I think it wasn't too bad. Right? So now you can take this data, and what you can do is take the movie, clip it into short clips, and then you want to do some matching. So you want to compute a similarity between each clip and a particular sentence in the book. And you can use a neural net to do this for you. Okay, so then hopefully, if sound works, you're going to see a clip from Harry Potter. And what you're going to hear is not the movie. You're going to hear the narration of the part of the book that this clip was matched to.
Harry, please relax, or Madame Pomfrey will have me thrown out. Harry swallowed and looked around him. He realized he must be in the hospital wing. He was lying in a bed with white linen sheets, and next to him was a table piled high with what looked like half the candy shop.
And then you can actually go crazy. So now we were matching a movie to its own book, but then you can take a movie that doesn't have a book and just match it to, like all sorts of books and try to find some paragraph that's gonna kind of best match with this clip. Right? So we did this for Batman. It got matched to some fan fiction clip.
I believe you will enjoy your time here. I am not a harsh master, but I am strict. When we are with others, I expect you to present yourself properly. What we do here in your room and in the dungeon is between you and I. It is a testament to the trust and respect we have for each other, and no one else needs to know about our arrangement. I'm sure the past few days have been overwhelming thus far, but I have tried to give you as much information as possible. Do you have any questions?
All right, so yeah, actually we do have questions, right? Because this grandma might actually have questions. Where are my glasses? Do I need an umbrella? And then she expects this robot to actually be able to answer these questions, right? So we also did something like this. So basically, this is what the current methods are doing. So they're taking a picture and they're putting a little quiz to the robot. So the robot needs to look at the picture and the question and then be able to answer it. All right? And then you can throw a lot of different questions to it. And the idea is, if you're able to answer any questions that someone can ask you about the picture, this really means that the robot is understanding what's there. All right? But there are just so many things you can ask about a single photo, right? What's there? Maybe what's the color? So it's kind of boring, right? But the picture, right? There's like the world is not static. There's actually a story behind every picture.
John, I'm sorry. They got us.
All right, so this like 20-second clip, actually, there's so many more rich questions that you can ask, right? So what's the relationship between characters? Why did this character lie to the other? What's gonna happen next? What's there? So there's so much more that you can ask. So our idea was not just take a single photo in a quiz, take 200,000 photos, so a full movie, and then give the robot a quiz. And now the robot needs to read this quiz and learn basically what's going on, so understand the story. Right? So this is basically our robots. So they're just chilling out and watching TV, watching videos, and basically learning how the world and people work, right? Basically what, how, and why things are happening, right? Don't worry. It's actually not working very well yet. It's a really challenging problem. 20% is random. The best we can do is 40%. But I think it's going to work, soon enough. All right, so what else do we need, right? So now they can talk to each other, they can ask questions, but this brings us to the basic thing why this grandma actually got the robot, right? To basically do stuff for her, right? Maybe she wants to have the robot make tea or coffee and so on. Right? So basically, the robot needs to take action, not just perceive the world. Right? Now imagine a scenario. So you have this grandma, and then says, make me coffee. Right? And now there is all these robots already out there that have been pre-programmed to know how to do coffee. Right? All the steps that are there. Right? But maybe since the grandma actually bought the robot, things have changed. Right? The world is changing. Maybe she wants to do other stuff. Right? More interesting stuff. And then like crazy things happen every day. So there's right? So how can we actually have this robot to adapt and actually be able to follow anything that we're going to be asking it? Right? So here was our idea. So let's say that we actually ask the robot to do something that it has never heard how to do before. Right? So how would you do it as a human? You would describe the steps how to do it. You would describe kind of the recipe, do this and this and this in natural language. So the idea was, can the robot read this instruction just in natural language and self-program itself? Basically write code that it's going to be able to execute and actually learn how to do this task. Right? So what you see on the left is just kind of a set of really simple instructions, a sequence of instructions that the robot knows how to execute, but actually if it's executing it, then it basically does what the grandma wants. Right? So then in the end we can have an environment and then it knows how to do that stuff. Right? Luckily no sound. So here is a description. The robot reads this description, basically does its own code, and what you're going to see is this agent performing this action. This is actually done in a game engine called Unity. And it was done in collaboration, but the main driving force was actually a U of T undergrad. So he came to my office. He said, I don't know computer vision, but I have been programming games. And it was like, all right, you're hired. We're going to be doing this cool project. Right? So simulation is really the thing to do these days, because if you have the robot do stuff in a real environment, it can just go really wrong. So it's good. So it first needs to do stuff in the simulated environment. All right, so now we can kind of close the loop. It knows how to perceive, understand language, even do stuff. Right? But what else can we do, right? And since this grandma is actually kind of tech savvy, right? Maybe we can throw AI in her little phone and do all these nice things for her as well, right? So maybe she's interested in fashion or other possible applications. So our idea was, can you take a photo and maybe the user is going to tell you the setting, like going to the beach or something like that, and you want to predict how fashionable this user actually looks for the occasion. Okay? So what we did was take this website called Chicktopia, where basically a lot of style enthusiasts post their latest outfits, and then other people can vote on them. So basically tell you how well you actually look. And that was our proxy. So basically we took the number of votes, and this was our proxy as fashionability. This is the stuff that you want to predict when someone shows you their photo. All right? So this is basically our model, thinking that these people are fashionable. So this is a prediction. And the nice thing is that it, as a side effect, it can also discover styles. Right? So imagine you give it a photo, and then basically it's able to show you the pictures of all the other people that have the same style. Maybe that gives you some idea of what you want to wear next. Right? It can also do recommendations. So let's say that this photo doesn't maybe look so good, and it's going to tell you, maybe you want to wear something else to increase how well you look for the occasion. And maybe that gives you some idea, and maybe you just want to describe in a little bit more detail of what you want to kind of see on yourself, and then you can actually generate that kind of clothing on the user. Right? And maybe the user wants to say something else, a blue shirt, and then you can generate that kind of clothing. Right? So in a couple of minutes, you can actually see so many outfits on yourself and kind of see what goes well on you. And maybe, just maybe, that's the only way to get a nerd like me in Cosmopolitan. It was the first moment, and my mom was actually proud. All right, so this project was actually thanks to Edgar. Should I say Edgar before the project? All right, so I hope that in this 15, maybe a little bit more minutes, I have convinced you that AI is the thing to do and that AI is the new cool. So you should all be working on it.